Welcome to, I guess, step 2 for the French cleat wall. We're going to start by making the first of our tool holders. In this case, it's going to be the holder for the oscilloscope. And I did a CAD drawing that I showed when I created the French cleat wall. And I did a design for an oscilloscope holder. I revved it a few times. And we have essentially the side that looks like that. And it'll look like that. This is the top. There's a cleat back here to hook it on. This isn't shown here. And then there's a hole in the side. One end, that's a fan. And the other end happens to be the power cord. So, and this piece of paper is, I made up the design, I exported out the cleat, and then I held it up to the oscilloscope to see if it made sense. And I did that a couple times, and this is kind of the end shape. Now I could have just traced this on a piece of wood and used that, but I have a fun toy we're going to play with. And this toy here, well, zoom in so you're looking at the toy rather than me. So this fun toy is what's known as a shaper origin. And what it is it's a computer controlled router, or a CNC controlled router. So here in the base we have a typical router motor. It happens to be made by Festool, who does really nice tools. And then it is hung on what's called a motion base. Take off a guard or two. The motion base allows the router to move. It can move this way or this way on servos. And so that's the business end. We turn around the other side. Here we have a camera and a vision system. And this whole box here is a pretty advanced computer system. And what it does is it looks at these little, what they call dominoes. So little fiducial markers or position markers. So when I move the router around, it has a model and it knows where it is. So I can download my design into it, and it knows where it wants to cut. When I move it around, it knows where the bit should be, and it uses the servos to guide the bit. I'll trace around where I want to cut very roughly, and it will move the bit around to keep it on the line. So, pretty fun little tool. I've used it on a few projects. And it's just kind of a nice, different way of doing it. I'll do some things traditionally, some things with the shaper. So it'll take me a minute to get set up. I'll try to get the camera in a position where you can actually watch. Might be kind of challenging, so we'll see. So you may have noticed kind of dark in here now. The LED overhead shop lights I have work fine, except they flash at a high rate, and that flashing confuses the shaper. So we've taken to running it. It has built-in lights, and we've been taken to running it with just the built-in lights. Now I don't expect you to see the screen, but basically the first step is, so you can kind of see here, I have some of these dominoes across, and the first step is to scan them to kind of establish a model. That way the router knows where it is. And I may need to add some here to give it more points of reference. And I have one piece here with the dominoes on it, which is the piece I sometimes use for that. And the piece I'm actually cutting is close. The router's sitting on it. So I go in, I start a new scan, and basically I just move the router around, and it shows me which of those dominoes it has found. I tell it to finish, and it'll go through. Now it's building a workspace. So it's basically figuring, taking all the pictures it shot during that scan and giving me a model. Now we'll see if my Wi-Fi is working. Okay, this is going to take a moment. I'm going to shut off. Okay, back again. I had to rehook it up. The router does wireless, and I changed my wireless configuration. So I hooked it up, I logged it in, and I'd uploaded the design to the Shaper website. You can also just put it on a USB key if you think that's easier. It probably would have been. So I now have the SVG that I designed, and I'm going to do 2 versions of it. I'm going to try rotating it. I'm just trying to judge how much space I have. I want it over towards the plywood. I have some clamps holding the plywood down that I'll probably have to move around, cut one and then the other, which is pretty typical when doing this. And I obviously try one more rotation. That's probably better. Yeah. I can go back to where I started. I obviously need to make sure that when I place it, and when I'm placing it here, I'm actually moving the router around, and the camera is showing me where it sees the wood. So I can see if I look, if I move forward, I'll be on this piece, and issues like that. So I'm going to try to eyeball a little bit, see if I can actually fit 2 of these side by side. I think I can pretty easily. Okay. I get it where I want. I hit place. Go back. I'll place the same piece again. Okay. So now I have 2 places. Now I can flip over to the cut menu. And the cut menu very nicely shows me the outline, and it shows me the bit I want to use to cut. I'm going to, these things have a hole in the middle, and I'm going to go cut the holes in the middle first. Yeah, that's on. And now I'm just scanning around, kind of looking to see what I'm going to need to cut. And it looks like we'll be pretty good. I have one part, there's a little part where the cleat hangs. You know, the top is a very sharp edge, that sharp 45-degree angle. And because I have a 1/4 inch bit in here, I actually can't cut that. It'll be kind of rounded, so we're going to have to clean that up with the saw afterwards. So, but that'll be pretty easy. Okay, so what do I need? I have another light on here that it's hard to see. I have dust collection hooked up, which is nice. Once again, I'm going to have to turn on my very loud shop vac, and the shaper is kind of loud too. So yeah. So those are the two vents cut out, and you can see they're pretty nice dimensionally. The router is actually amazingly accurate. Now, because it's obviously a small motor and it's limited in power, you can't do big beefy stuff all at once like you would with a fixed CNC. So there I had to do 4 passes, about 2 millimeters each. And those are cut out, and now I'm going to flip out. I cut those out on the inside, and now I can go and cut around the outside. So that's next. And here we are after cutting. And here are our two little pieces. Hang quite nicely. There's a lot of buzz here, the fluff and stuff. Really not much of a surprise. The router bit I have in there is not one of the greatest. And then that part right there isn't sharp enough. I'd forgotten. What you normally do is you do what's called a dog bone. You essentially take here, and instead of cutting straight, you cut down a little there and then out a little to this side and kind of make a bigger circle, and that way you can fit the part in. Yeah, I forgot to do that, so I'll just have to do these myself. So we have this piece, and then I have a cross piece, and so I'm going to make those and sand this up, and then I'll come back when we do assembly. Welcome back. It's finally time to do some assembly. I have a nice base that I made, and then these are the two pieces. And they're all nicely clean and sanded, and I test fit. It turns out the cleats on the board are a little, not quite half an inch deep, or not quite 3/4 deep, so I had to do a little modification. And so we have the base, and the base was originally designed to be 1/2 inch, and this is approximately 1/4 inch. And I decided, you know, the oscilloscope doesn't weigh much. I can't bend this at all, or maybe just barely. So it's obviously more than strong enough. The question is, how am I going to get a strong enough connection between this piece and these pieces? So I've decided I'm going to take a two-part approach. First, we're going to get some glue on there. Not much, because it's really a pretty thin piece. That may be too much. This is, however, an oscilloscope holder. It's not a piece of fine furniture. So now I need some mechanical way of doing it, and I've decided I'm going to use my pin nailer. And the pins that this shoots come in a little strip. You can see they're really tiny. I think those are 5/8. So very, very tiny and not very long, which makes them pretty much perfect for this. I have this little block behind to help hold it at the right angle. I can slide over. And those pins really give a remarkable amount of strength. I need to sand them down a little bit. So now I have the pins there. I'll do the other end, and then I'm going to clamp it anyway, lightly. Make sure this points the right way. I put 5 pins in the last one. I actually don't think I need quite 5. Now the nice part about the pins is they're so tiny they really don't disrupt. There's very little chance that I would have split the piece I'm shooting into. So now before I clamp it, let's just have some fun. And what do you think? Is it going to work? And there's our first piece. And the whole point of this, the French cleats, you notice, it sits there, but boy, it doesn't really want to go anywhere, does it? It's a very, very solid connection, but we'll move it to another one. Really simple and quick. So let's get a clamp on that lightly, and then I think we'll be done. I just want a little tension here. I don't want to. That's more than enough. There we are. We'll let that dry, and then it'll be time to take the board inside, install it, and then put the scope on it, and then I can move on to doing the next one. Thanks. Hey, welcome back. So here is showing the French cleat panel in the proper position. So I have that done, and the oscilloscope shelf is all ready to dry, so all ready to put up. So all I need to do is attach this to the wall, and then we'll put the oscilloscope on, and that'll be done, at least for the first part. And the panel location isn't really that important. I can go left or right. All I'm going to attach it, this is pretty heavy, and all the weight will be borne by the countertop. So I don't really have to worry about a ton of attachment, but I'm going to put a single screw into a stud. So that's the tapping method for finding a stud. I also happen to have, we'll see if I can find something. You can use a little magnet too to try to find it. But I'm just going to assume. Pretty good chance that's right. Oh yeah. Okay, so one screw, and there's no way that's coming down. Okay, on with the fun. So here's the nice completed holder, all nice and dry, all ready to go up. What the height should be. I don't have to play around with height and arrangement, obviously that's one of the cool things for doing this. But and I didn't actually test fit this, so I may look really stupid here in a second. Ta. I'm not quite sure what to do with the probes yet. The probes may get their own little holder on the side. For now, I'll do what I've done in the past, which is and kind of just stuff them on top. Obviously not the best solution, but a pretty good one. And the nice part, so I guess I can slide it out of the way. So it's kind of off to the side, doesn't get in my face, and I'll bring it back when I need it. I think it may up one. So that's the first one, and that already has given me a little more space here. Coming up next, my fluke meter. If I get a little closer with that. My fluke 73.3, which I've had for, I don't know, 20 years. Still my main meter. That, and I'm not sure I'm going to do, I might pop it out of the plastic. I might do a holder just for the meter part here. Or I might try to do a holder that does the plastic. The nice part about the plastic is the rubber is then, if I need to take it someplace, I can just pull it out. And that's probably a nicer thing to do, which I do need to do sometimes. And I also want to do something for the leads, so they aren't just coiled on the workbench and caught up like you saw. But that'll be the next project. And then after that, I'm going to do something with this power supply, and I think I'm going to do something fun. Sorry, you can't see the power supply. So this is my also fairly old Elenco Precision Quad power supply. So it gives plus 12, minus 12, plus 5, and then it also has an adjustable output. And I have that. I want to do something with that. I think I'm going to do something kind of cool with that I hope will make it take up less space. And then hanging over here, I have a 12-volt brick. Hanging over there, I have a 12-volt Xbox 360 power supply that I want to convert. And then I also realized I have my resistance decade box, and that usually just clutters up the bench, and I'd probably use this more if it was mounted on the wall, and I could actually just plug the test leads into it and do the normal thing. So I think that this will probably get something too. And so that's what's coming up. I'll do short videos for those, because they're going to be very exciting. And that's going to help a lot on the left side. Pan over to the right side. Boy, that's still a mess. I have the rework station and the soldering station, the soldering iron, and I'm not sure if I can do anything with those. I guess I could mount them up on another wall, but I'm not sure that really gains me anything. Maybe it does. I'm going to have to think about that a little bit. Maybe having both of those up and just having the soldering iron holder would help. Although the rework cable tube, hot air tube, is more than a little annoying. So, thank you. See you soon.